Good afternoon, good evening, good morning from wherever you are today. My name is Sarah and I'm the Program and Event Manager at the Reactor in Sydney. Welcome to another Microsoft Reactor Sydney live stream event. Today I would like to welcome Rodney Joyce. Rodney is the Managing Director at Data Driven with 20 years experience of software.
Oh, Sarah, we lost you there.
Oops, apologies. Can you still hear me, Rodney?
We can now, yes.
Okay, great. Sorry, everyone. I think it's on my end. So just a couple of housekeeping notes. This session will be approximately 60 minutes with about 10 minutes for questions at the end. Today's session is on, Rodney will be sharing top tips on how to lower your cloud costs on Azure and save money and avoid bill shock. At the conclusion of this session, I will share a link to the feedback survey in the Q&A section, and also letting you know that there will be an on-demand version of this in the next 24 to 48 hours on YouTube. But without further ado, I'd like to hand the floor over to Rodney to begin. So Rodney, over to you.
Great, thanks, Sarah. Okay, sorry for the technical glitches, as Sarah mentioned. It's just one of those days. So I'll try to make up some time. This will be recorded though, so you do have time to watch it later if you have to drop out. Okay, so today's talk is about implementing an effective cloud cost-saving strategy, and we're going to talk about why we would do this and how to go about doing this. So first of all, a bit about me. My name is Rodney Joyce. I'm the Managing Director of Data Driven. So we deliver data and AI solutions to our customers. We're a consultancy. We focus only on the Azure platform, but I want to point out that this webinar today applies to any of the clouds. It's very cloud agnostic. Some of the terms I use might be Azure specific, but they do apply to any cloud. Okay, so at Data Driven, we basically help our customers get from where they are currently to where they want to be with their data strategy. Our speciality is our modern data platform, which enables advanced analytics and self-service and helps customers get more value out of their data. And we look at modernizing our customers' business processes and software to basically let them focus on getting more value out of their data. So I'll just go over the contents for today. 1 second. So firstly, we'll look at why do we need a cost strategy, and we just want to point out the problem statement that we're trying to solve here. We're going to look at what causes cost to spiral out of control. We're going to look at some of the common misconceptions when it comes to the cloud. Then we're going to look at the solution. So we use a 5-step cost management process that helps solve this problem and alleviate or lower the cloud costs. We'll look at from a more development-focused angle for cloud savings, and I'll introduce you to a tool called Cloud Monitor that can help you do all of this too. And then we'll have some time for questions. Okay, so first of all, discussing the actual problem. Why do we need a cloud cost strategy? So if you look at the Flexera 2021 State of the Cloud report, cost saving is the #1 initiative for the last 5 years across all respondents. So everyone believes that they can optimize and save more money on the cloud. 30% of these respondents also feel that they waste money, and I'm pretty sure that the problem is actually bigger than that. Now, the good news is that with a good cost strategy, we can get those costs right down, usually by 30 to 50%, depending on a few factors like the maturity of your current governance process, your dev team awareness, and your maturity with the cloud. But you know, gains of 30% are not uncommon, and that results in direct saving to the business. It's worth pointing out that this problem is not just a big company problem. Every company has this, just at a smaller scale. So even ourselves at Data Driven, we've got around 10 consultants. On our own internal systems, we sometimes face cost wastage that we have to try and fix up. Okay, so excuse me, what causes the cost to spiral? Now, by the very nature of the cloud, it's designed to allow self-service innovation. So it's focus is basically on rapid development. Now that kind of goes against governance and process and keeping track of costs. So we've got to find a healthy balance between these two. So the first major problem we have is that there's a lack of visibility on your cloud expenditure. Now what I mean by that is that the people who should be looking at the costs are not getting the right kind of reports, and not getting the visibility on what's being spent. And the people who are spinning up the resources don't have the visibility either on what's being spent. Now this is down to a few different reasons. The tooling is not great. It's lacking in functionality. It's very textual. It's not a great user experience, and it just doesn't help you do your job basically to lower costs. So without visibility, we can't understand the extent of the problem. So there's the other challenge to this is that there's a business lens and a technical lens to this problem, and we need the input from both sides of the fence. We have to look at how we're meeting the business requirement with our technical solution. The second problem is this disconnect between the resource creator and the bill payer. So the person who spins up resource is often a developer in a dev team. They've been given the remit of building a system normally as quickly as possible. They're on a tight budget. They're working in sprints. Their top priority is deploying the system and getting it working. If they hit a performance issue, the first thing they're going to do is scale up. They're not going to think about, do we have budget for this? How big is the budget for this project? They haven't been given that kind of information. On the other side of the fence, you've got the bill payer, who is way up the food chain. They're not necessarily a technical person. They don't understand the complexities of the cloud system and the different services there are. They don't understand necessarily the effect of scaling up and down, horizontal scaling, vertical scaling, and there's all these different terms that they wouldn't be privy to. They do know, however, the amount they're paying each month. That bill also comes in 6 weeks later. So the person creates a resource. 6 weeks later, the effect of that resource is finally seen by someone in the system. So we've got this huge disconnect between the person paying the bills and the person who's making the resource. On top of that, due to the permissions nature of the cloud, the person who's making the resource often is not given permission to see costs. At the very least, he should be given permission on his own little group to see what the effect of his choices have, but he's not given that visibility. He also doesn't want to risk disrupting the status quo. So if he sees a cost opportunity or a cost saving opportunity, he's not necessarily going to action that because it's a risk to the system. It's not his first priority. The third issue is probably one of the biggest ones. It's the lack of governance. So governance is a very big topic in cloud management, and it basically is how do you manage and enforce best practices and standards across the cloud, and it applies to security, costs, access, all sorts of different things. Now we're going to deep dive into each of these topics in a little bit more detail, and we'll discuss how we can apply better governance to our system. But basically, the premise is that preventive maintenance is the cheapest way of preventing your costs from spiraling. The fourth problem, and I mentioned it slightly before, is the limitation of the inbuilt cloud tooling. So it's very basic. It's not as helpful as it could be. Let's just say that. And this is across all the different clouds. The fifth issue is that PaaS services in the cloud are complex by nature. So in the old days, when we had a VM or an on-prem system, you had a compute system like a server, you had a web server, and you had a SQL database, very basic client-server application, and you provisioned the whole lot. So it was a CapEx charge. You bought a big server, you provisioned it, and that was it. That was your costs. You didn't have the ongoing bills to pay for the use of the service. It wasn't measured by time. It was basically a once-off payment, and that was the price. Now, the less tangible benefits of the cloud are things like elastic scale, PAYG pricing, distributed geo redundancy. There's thousands of benefits why we move to the cloud, but cost is not one of the things that was unfortunately one of the easier changes when moving to the cloud. So for example, with Azure Data Factory, one of the key components of Azure, you might have 10 different meters for that one component, things like data ingress, data egress, compute, all sorts of different nuances as to how to measure that particular service. And it requires a fair bit of understanding of that service to know how your actions will affect the costs. And this ties up to the last point, the developer awareness. Now, technology and the services are changing all the time. It's very hard to stay on top of these new services, new functionality. One wrong click on a service could result in a huge bill 6 weeks later to the bill payer. So the developer is not even necessarily going to be aware of the cost increase that he's caused just by accidentally clicking the wrong button. The governance part plays in here because nothing prevents you from doing it. So even in my team of really experienced consultants, we've all blown through our MSDN free credits for the month because we've left the Databricks cluster running, or we've spun up a data warehouse and forgot about it. It's very easy to make expensive mistakes on the cloud. In addition to that, the cloud is basically allowing us to a magnitude of scale, and the downside of that is that cost is included in that scale. So one small mistake can be a really expensive cost. Okay, so all of these 6 problems together are the main contributors of the chaos that manifests itself as higher usage and therefore higher costs. Now, some of the misconceptions around the cloud contribute to these previous factors. So some people think that moving to the cloud will immediately save costs and automatically save costs. And we know that's not true. So as I mentioned earlier, on-prem is very fixed. It's a CapEx cost, whereas cloud is very complicated. So that is completely incorrect, that statement. We've also seen examples where customers that are lift and shift. So, they've heard that they have to get onto the cloud. The easiest way is to just lift and shift all your current on-prem systems onto VMs and put them in the cloud. And there's nothing wrong with that. It's completely true. That is the easiest way to get into the cloud, but it's not really taking advantage of the true PaaS services and cloud native opportunities, things like elastic scale and PYG pricing. So it should be very much considered a temporary option. Do not lift and shift and then forget about it. Lift and shift as a temporary stage in your cloud migration strategy. So we saw an example where these VMs were huge. They were on all the time because they had multiple web services, multiple SQL servers. They were paying for different SQL licenses, huge compute, huge disks, and there really was no need to have that running all the time. If it had been a distributed, decoupled architecture, then different parts of the system could have been paused or scaled down depending on the requirement. But a monolithic VM reduces the need to reduces the ability to be able to do that. Excuse me. The third option is the third expectation is that we assume that cloud optimization or cloud cost optimization is built into the cloud service. Now, it is true that there are services like recommendation engines, cost anomaly detection. There's a few other few reporting tools, but they're very, very basic. They're not contextually designed to match your business. I don't think it's possible that the cloud provider could consider every single business case out there and make a service that could, match every single person's requirement. So they're very high level, very generic. Yes, they cannot be relied on to lower your costs. Also, people think that you invest in cost optimization, you set it up and you run once and you forget about it. That's completely untrue. So because the cloud is changing, that's the continual variable that's changing, that forces change upon you. You need to constantly review your strategy and make sure that you're adapting to those changes. You also have to make sure that what you've done applies in the future. So business requirements change, technology changes, people come and go. You have to keep reviewing this stuff. And this is what I mentioned in point 3, definitely the built-in management tools are not helpful enough. Okay, so the good news is that there is a solution for this. So we have a 5-step cost management process. It's very cloud agnostic. It will work on any cloud. This is very healthy. It's an iterative, continual, infinite loop of optimization. So the first step is to understand your costs. You cannot optimize anything unless you benchmark, measure, and understand what you want to improve. Now, this is obviously fairly challenging, and we'll dig into each of these in more detail. Once we understand our costs, we can now put a plan in place to improve them. This is not necessarily just a technical problem. It's a business problem, a process problem, a governance problem. There's different people from the business will be required to be involved in order to solve this challenge. The third step is to actually take action and implement those cost-saving recommendations and opportunities and measure the result. So we have to also make sure that we haven't damaged production or change anything that could be a risk to a business critical system. So we have to do all this without affecting our customers, which is really challenging. That little caveat adds a whole nother level of complexity to the equation. The fourth step is to make sure that we have preventative maintenance policies in place that prevent us doing things that we shouldn't be doing. And we have the standardization and best practices built across the business. And lastly, we have to educate everyone involved in the cost management cycle about these costs to build a kind of data-driven, cost-aware culture about cloud costs. Now, it sounds really simple, but we'll drill into each of these, and I'll show you it's not as simple as it sounds. Okay, so the first step is understanding your costs. So firstly, you need to find a tool that works for you, that lets you analyze and report on cloud spend. So there's a few different features that you should be looking for. You want to have a tool that allows self-service reporting. So it should be really easy to go in, slice and dice the data, find the top expenses by whatever metric you're looking for. Different problems, different systems, different requirements will all have different results or processes as to how you find that data. So it has to be a very flexible tool, and it's got to have analytical features. You've got to be able to compare your actual costs, your expenditure, versus your budget, what you plan to spend, and your forecast. So, for example, if I say I want to spend $1,000 this month and I spend $900 on the first day, I haven't hit my budget yet, but I can predict that my forecast is going to exceed my budget. So you need tooling that can handle that scenario. The third point is that the cloud tooling natively in the clouds is very technical, and the cloud is generally used by technical staff, so that's understandable. However, we don't build systems like that. We build systems that are composed of multiple resources, multiple resource groups, multiple subscriptions in the Azure environment, and all of those components together comprise a system that's performing meeting a customer's requirement, and someone's paying for that system. Someone's worked out that will drive business into the organization, and that's worth it. And the cost that you sell that business for will exceed the cost that you're paying. So we really want to see things from a business point of view, not a technical hierarchy. So I'm using the term business unit. You could use cost group or cost hub or cost center. There's different terms for it, but the point is that it's not a technical hierarchy. Number 4, ideally, we're going to be sending cost reports to the business unit owners. That's generally the person who's paying for the system. So we want them to have very good visibility as often as possible. They can still go in at any point and browse the system proactively, but at the very least, they should be getting an email to their inbox every month saying, this is what this system has cost you. And that will drive change if required. And then number 5, you really want a reporting tool that can give you visibility that's extensible. So every business is slightly different, every project slightly different. You must be able to extend this, ideally using the skills that you have in your current company. Okay, so as I mentioned earlier, the cloud providers have some of these features and different maturity levels within these features. I would recommend extracting the granular data from the clouds, so the actual usage data, and connecting it with a business intelligence tool like Looker, Tableau, Power BI, whatever you're familiar with, ideally with something that you can reuse the skills from within your organization to build models that suit you. Here's an example of a standard Azure invoice on the left-hand side versus a custom BI report. So we built this BI report for a customer of ours. They wanted to understand their costs. We built some KPIs. You know, what is the current period cost? How does it compare to the previous period? And that's all changeable by year, month, day, financial year. What's the projected financial year cost? What's the price per day? How many resources, subscriptions, what kind of thing you have in your estate? And then this very flexible reporting that you can drill down into by day. You can see averages, you can see trends, and you can see this by business unit, not by a technical subscription. It's actually by a complete encompassment of different subscriptions. Now you can see the one on the left is what's currently going out to the bill payer, and I can assure you that the program manager of your system doesn't know why LRS data store general block blob cost $1.90, and nor should they. So that's one of the problems that exists right now with cost visibility. Okay, so once we've identified, we've got cost visibility, we've got understanding of our costs, we can see there's a problem, we have to put a plan in place to solve this problem. So the first step is to organize meetings with the stakeholders from tech and business. So this is one of the key changes that we're proposing. You've got to involve the tech and the business here. Benchmark the current system over time. So you get anomalies, so you want to make sure that you have a very accurate sample of data. So understand what it is that you want to change from which value to which value. Look for the low-hanging fruit, and you can do this by doing a cost-benefit analysis. So in this case, your cost-benefit would be basically the effort required, including also the risk of making these changes versus the benefit that it can bring back. So some examples might be, what are the top expenses? So many times in big data systems, it's the usual culprits like data warehouses, analysis services, Databricks, you know, the really big shared components that are used by multiple different use cases. They generally have the potential for the highest costs. Now, obviously, you can't just go and pause that or shut it down, but it's probably a good place to start with your top expenses and see if there's any room for opportunity. It might be worth some time looking very quickly through the system. Is there anything that's obviously no longer used? So we're talking about whole systems here. Someone did a POC, they got the insights from the POC, the vendor that they used to deliver the POC left ages ago. No one paused it because it wasn't in their remit to pause it. It's still consuming costs. The person who paid for the project, he's actually left for a different company a year ago. No one knows what these resources are doing. There's tools that make these kind of resources and systems easier to find, but there's some really low-hanging fruit there to eliminate. And another very easy low-hanging fruit is to check whether you're taking advantage of the true PaaS capabilities of the cloud. So I'm going to go over this theme a few times, but basically, if your customers only use your service or product during their business work days, let's say Monday to Friday, 9 a.m. to 5 p.m., 40 hours a week, why would you run your system and these expensive components all the time over public holidays, over weekend, overnight, from 6 a.m. to 9 a.m.? There's a lot of very easy money to be saved there with some smart scheduling. We'll go into a lot more opportunities in number 3 later. Once you've identified what you will be changing, next you have to do a governance maturity assessment. So this is looking at, how well are you managing and governing your resources and your processes and your people. This is not a trivial exercise, and that's a whole topic on itself, but the point is you want to work out where you are currently in your governance and where you need to be. Then you make a plan and you make someone accountable for that plan. So that person is going to be the one that's driving, weekly updates. Are we making progress? Have we damaged, have we touched anything that was business critical that shouldn't have happened? Are we ticking all the right boxes, and are we actually lowering costs? So someone needs to be accountable for the overall delivery of that plan. Okay, the third step is the more interesting one, which is how do you actually take action and optimize your usage? Now, some of these terms I'm going to use are probably very Azure specific, but every cloud has a similar concept or service. So the number one biggest way to save money is to prepay for certain services. So in Azure, we have this thing called reserved instances, and it applies across different services. You have storage, VMs, Databricks compute instances. There's a whole stack of different things where you can now prepay in advance for a year or 2 years or 3 years, and you'll get it at a much cheaper rate than if you pay PAYG. You should be aware that there's often a price point before which it makes sense to do this. So we did a cost optimization assessment on a data lake. It was storing huge amounts of data every week, and it actually only made sense to buy the reserved instance when we hit 100 terabytes of data. Any purchase before that would actually have been a loss, because we're only ingesting 5 terabytes a week. So therefore, we actually would be overpaying if we bought that too soon. So we came up with a plan at which month it made sense to move up to the next tier of reserved instance. Each component and service will have its own nuances that need to be considered. It's not just a case of saying, yes, I want a reserved instance. It needs to be thought in quite great detail. Okay, so secondly, there's many benefits for development versus production. So Azure, for example, will give you a dev test lab for testing out different VM scenarios. It's much, much cheaper than a production instance. There's developer licenses for SQL, there's VM developer licenses. There's something called the hybrid license, which is where you already have an on-prem SQL license, and you on good faith tell Azure that you have that license, and they reduce the cost of your VM. Now, this is definitely worth looking at for your development instances or environments. It's not so useful in production, but it's still worth looking at. So thirdly, you should be looking at, are you taking advantage of the natural or native PaaS capabilities of every service? So for example, Databricks is a good example. It scales automatically. Are you shutting it down automatically when it's finished its load? Are you pausing your data warehouse automatically when it's no longer needed? All these features are built into the product. A lot of them have very nice interfaces via the UI, via ARM, via PowerShell, or via API to go and enable these things. But you actually have to make take the step to enable it to bring according to your business schedule. The fourth optimization is right sizing. So this chart on the right-hand side basically describes what right sizing is. So it's looking at the metrics and utilization of a resource, and this applies to pretty much any resource. So let's take, for example, a SQL database. We provision a database, let's say it's at 100 units, whatever, and we use 5 units. We know that 95 units of that database is being wasted. So we have a few options. We could either provision a serverless database, if such a thing exists on your cloud, which would basically scale up, compute the query that you've given it, and scale down again. That is the most kind of efficient pay-per-query service there is, but a lot of clouds don't have those capabilities yet. Then you've got the model where you say, okay, I'm going to provision a fixed instance for a period of time, but it can scale up and down with automation. That's another option. Another option might be to make a pool of SQL databases where you say the total pool size is 100 units or 1,000 units. Each database could use 100 units depending on what it does, but the max you'll ever pay is 1,000 units, as opposed to having 10 different databases, each with 1,000 units, which would be 10,000. So the whole concept of utilization versus metrics is one that really needs to be understood well. It's also specific per each resource or each service. So for example, if an app service or a Kubernetes website is running at 80% utilization, and utilization is a bit of a generic term. There's hundreds of different metrics that need to be measured: compute, memory size, read, write, I/O, all sorts of things. But let's just assume that there's a simplification of this. If it's running at 80%, at what point would reducing the size and increasing the utilization affect the performance? And that's this middle part here where we have performance risk. So we made it too small, and the end user notices a difference in performance. And depending on your business, that could be really, really bad and really costly. You might want to avoid that situation completely and always keep this buffer above it. But each service will be different. Now, it's probably worth starting with the big services like a data warehouse or a big database, and checking that at the very least you're around 60 to 80% utilization. If you're on 5%, it's an obvious candidate for downsizing. So you just make it smaller, and that's that. Number 5 is to remove zombie resources. So these are the individual resources that no longer are useful and contributing. They're not used anymore. You can normally tell this by looking at the utilization charts. If you can see that no one's ever used the website for the last 3 years, it's probably pause it and then mark it for deletion and go through a certain process and then remove it completely. Another very easy one is your workloads. As I mentioned earlier, if you're not using a service all the time, pause it in the time you're not using it. That's a very easy way to save money. So utilization basically is 0 and your cost is 0. Another area we see lots of extra costs is in unnecessary backup requirements. So this comes into your organization's disaster recovery plan and your point in time restore point and RPO requirements. But basically, do you really need to have your data geo-replicated across 10 zones? Could you risk having it across a single zone, for example? Each of those changes will result in more cost. Now, it's going to depend exactly on what the resource is, what the data is, what the business criticality is, but often there's scope for reducing the backup requirements at a component level. Another thing we see lots of opportunity in is your data storage requirements. So in Azure, we have things like, are you doing hot or cold analytics? Are you querying the data all the time? Or is there a latency which is acceptable where you'll pay a lower cost for a read? You also have a third tier, which is archival. So we use this in data lakes quite a lot. If we're ingesting raw data, we convert it into a hot zone for low latency reading. We can take that raw data, put it into an archive zone, and forget about it. We'll never read it again, but we do want to keep it forever, because that's the new hot thing on the cloud, is your data is there forever. If you ever did need it, or someone thought of a new use case, you could get out of storage and restore it and get analytics out of it. You have to be aware though that the cost for a read on archival tier is significantly higher than if you're reading on the cold or hot tier. So you have to do probability modeling to work out what is the probability of you ever having to access that data again, because it might completely void your cost savings if you do have to access it. The format of your storage, your data in the storage is very important. So if I'm storing JSON, for example, it's going to be really big. If I'm storing Parquet, a file format that's really optimized for compression and storage, it's going to be 1/30 of the size and therefore 1/30 of the cost. So you might say, well, let's compress all our archive zone data into a much smaller format. These concepts are all quite specific to a big data platform, but they do kind of apply to other systems as well. And then you have to look at your costs around ingress and egress. So there's often hidden costs. For example, we saw a system where someone had the requirement to pull data from an API every minute. Now, there's about 30 different resources in Azure that you could use. I'd say most likely a Lambda is your best bet with that. So it spins up, gets the data, spins down again. But this person, whoever did the project, had chosen to use Data Factory, which seems like a good choice because it's the orchestration tool in Azure. However, it's not designed for low latency reads. So it was spinning up every minute, making an API call and spinning down. And we saw the costs were massive on the system, and we had to dig real deep to find out that there was a data read and write charge from a meter that we'd never seen before. That basically, in this particular situation where you're using it at high frequency, it's a big no-no. So we basically redesigned that and pulled it out into a function to lower that cost. Another example might be if you've got a Spark server like Databricks and you're making an API call, which is kind of not what Spark's intended for, but it's very convenient Python hosting library. You're calling an API every minute. It means your cluster has to be on all the time to service that call. So even though it seems like a very simple and easy place to put your API call, it just is not the best tool to use. So I guess what I'm saying is that your architectural choices have a huge impact on cost. And this is where you need to know all the different ways of storing data, retrieving data, to understand what the best component is. And that also depends on your use case and requirements. Another example is looking at, sorry, I've done that one, looking at the pricing structures for each component and your use cases. So there's a type of VM across all the clouds that handles sporadic activity really well, and there's other VMs that don't. So in Azure, it's the B series VMs, it's the B is for burst. And if you have a use case where you're reading completely randomly and then stopping completely, this is the best VM to use because it sells back the unused time back to Azure. Now, obviously, a lot of people don't know that. It's again an example of where you have to know these things to make sure you're using the right service for the job. There's a lot more that can be done here. These are kind of the top 10 main low-hanging fruit for optimization. Okay, so moving on to the fourth step, setting up good governance. So enforced preventative maintenance is the easiest way to reduce the management chaos in large systems. Now, the key word there is enforce or enforced. So things like enforce good resource naming conventions. I recommend going with the standard. All the clouds have their own standards. They're quite similar. They follow logical principles, and unless you have a very good reason to deviate, try not to. Often it gets dictated by your group IT policy. Sometimes those policies are very outdated, and they're not keeping up with the pace of change, which might have a detrimental effect on your system. So just be aware of that. So the second thing you have to do, make sure that every single resource and every single group of resources above that has a person who is accountable, and that's the owner. So if something goes wrong or there's a high cost or anything to do with that resource, you know who to talk to. If that person leaves, have a process that offboards that person and onboards the next person. Have automation tools that work out when a resource doesn't have an owner. Obviously, this, you can imagine the scale of this is quite difficult, but with automation, it's really pretty simple. Do things like set up monthly cost reports to be emailed to the stakeholders of the systems. Set up cost alerts when costs exceed the budget or the forecast. All of this functionality is built into the cloud, so that the tooling is there. It's just not turned on by default because they don't know what your particular business or use cases are. So make sure you go in. What we do in our modern data platform called the Data Foundation that we deploy for customers, we have all the stuff built in that's deployed automatically with scripts. So our DevOps process basically turns on alerting, turns on logging, turns on security to make sure that we always have this stuff enabled. The fifth one is to set up alerts on cost anomalies. So this is really a real no-brainer. If I spend $1,000 yesterday and I spent $2,000 today, I think I should know about that. So there could be a very good reason. Maybe you added a new component, but at least someone should go and check it out and say something changed. Was the change acceptable or not? And then your budgeting should be as granular as possible. So one of the limitations of budgeting in Azure, it doesn't take into account the pace of the budget. As I mentioned earlier, if I blow through 90% of my budget on day one, it's not going to necessarily tell me that that's a bad thing. I'd rather be told that the forecasted budget is going to be exceeded, and then get an alert to your owner. The seventh thing is to basically enforce the use of tags. So tags are a free-form tagging concept in most of the clouds. So it's a name value pair. You can put whatever you like, but they mean something to your business. So for example, you could put in the owner of the resource, the environment, the purpose, whether or not the data should be deleted by, when's the next data should be reviewed by. All of those tags, for those examples, if you don't actually go and enforce the review process, they're fairly useless. But without the tags there in the first place, you really have no way of knowing who created it and what it's for. Now, the good news is that the enforce part can be done with tooling in the system. Things like policies, blueprints, that's all very standard, very easy to do with automation. These things need to be turned on in your system. They often are dictated by your group IT policy. Some people think that they're not necessarily on dev. That's a real shame. So I've seen a system where production was the cheap system and dev was almost $500,000 of costs. No one knew what the costs were for. People had left the business. There were no tags. It was a complete mess of costs, and detangling that or untangling that and trying to figure out what was going on was a real hard challenge and very costly. So it's better to do this up front. Now, there's a lot of gains to be had by recognizing that dev and production could be different. So you don't need to necessarily have the same specs running in dev as you do in prod. You can share resources in development, which you can't do in prod necessarily. For example, you might have a single database servicing 5 different dev environments, and in prod you'd isolate that completely. You might also want to have a QA environment that is an exact replica of prod, but be aware that your costs would probably be almost similar to the production environment. So things like separating your environments by subscription or other logical boundaries is a good way for cost containment. And then in a system, for security reasons, try to use a single source of identity. So for example, Active Directory, don't give out tokens and use file drops and let people access things with a password. Put RBAC on everything. Let people log into, if they want to, integrate with your storage account, they can upload a file if they authenticate with Active Directory. So you can do things like have guest accounts for people that are not in your domain. It's very, very powerful. But if you don't know who's doing something, you can't take action. So you have to know who's doing something. And then you have to schedule regular review sessions of all of this stuff. So like I said, this is a continual iterative process. The fifth step is to make sure that the cost management strategy is built into your entire organization and it bridges the gap between technical and business for the reasons I mentioned earlier. So the 3 kind of main levels, you want to get buy-in from your executives. These are the guys that have the power to effect change in your organization, and they're the ones that say, yes, we will create a budget to solve this problem. The second level is your business owners. These are the program managers, project managers. They're the guys who own a particular system. They need to make sure that cost management and optimization is built into the project budget for development and post-project budgeting. They also need to understand things like how the requirements of the system, the customer schedules and things, can be turned into cost-saving opportunities. And then you've got your technical staff, and you've got the guys leading those teams. And these are the guys that need to be across the nuances of all these different components to understand the best architectural choices to lower your costs and to make things like decoupled systems and take advantage of the cloud. And these guys should be maintaining ensure that the backlog has cost management and optimization tasks in it, and they should be disseminating this information across the dev team. So it's not a single person's responsibility, it's basically the whole dev team's. Okay, so some of the best practices for development. You want to start small. If you develop a system and you deploy something, don't go make it a huge database. Start with the absolute smallest and scale up each time you hit a boundary. So for example, an app service in Azure, the free zone, it's free, but it can't have a custom domain name. You need a B1 license, and then a B1 license can't have deployment stops. So you need a standard license, but each of those, you want to understand why you're scaling up. You don't just want to deploy the largest service. So a lot of people deploy ARM templates they find on the web, and the ARM templates specify a setting for production, and they're deployed into development, and suddenly a week later the bills are huge and no one knows why. It's because if you deploy something in development, you should go, or into the system, you should go and review the size of your resources and make sure that it's right sized. Now, the architectural, I mentioned this before, the architectural design is key to the cost problem and to performance issues and a whole lot of other things. I won't go into that in too much detail. Your dev and prod environments will not be the same, and that's a good thing. You can save a lot of money on your dev environment. I highly recommend you use DevOps and automation to manage your environments. Do not do this stuff manually. It seems quick and easy, but you will pay for it in the long run with cost and your slowness of change. You'll slow down. So use DevOps for this stuff to pause and deploy environments. If you scale something up temporarily, set a notification or reminder. It seems very trivial, but you will forget why you scaled it up, and then you leave the business and no one knows why it's higher than it should be, and no one ever reviews it, so someone pays the bill down the line. Where possible, use horizontal scaling over vertical scaling. So this really depends on the use case and the actual problem, but it's often better to use multiple small instances as opposed to one big monolithic instance. It also reduces your single point of failure, but there's often some cost benefits to be saved there. When you're looking at integration, make sure you're looking at things like the frequency of your writes and reads to make sure your ingress and egress charges are low as possible. Now, some PaaS services come with a premium of cost, and often it's very acceptable because it gives you great benefits, but it's very easy to make a mistake. So one of the things we saw someone do once was in Azure Data Factory, there's a Spark-backed no-code option called Data Flow, and it's, from a business point of view, it's great what it does. It lets people who have no knowledge of Spark code highly scalable transformation pipelines. It sounds great, but you pay extra for that. So we did a proof of concept, and we used data flows, and it turned out it was ridiculously more expensive than if we had just written a Databricks notebook. Now you have to weigh up the cost of development, the cost of change. There's a total cost of ownership problem. It's not so simple as it sounds, but just be aware of their premium. IaaS is often more expensive than PaaS because it's a monolithic service, and it's either on or it's off. You can't pause and break things up into microservices. It's very monolithic. From the start, plan for redundancy. So understand for each item you deploy, what are the requirements for geo-replication? Does it have to be highly available? Can it be less available? What happens if there's a disaster? Get that in from development. Now, obviously, if you're making changes to your system, you've got to make sure that you're doing it the very low risk. And to reduce that risk, you do it on development first. I was working on a cost project once where, according to the utilization metrics, moving from a P6 SQL database down to a P5 appeared to have no effect. It seemed that I had, loads of compute free in the resource. However, the phone started ringing and the customers complained of a noticeable difference to the product. There was no ways I could predict that. So you have to be aware of this. You make a change as small as possible and you measure, especially if you're on production. Now, I'm just aware of the time. Some of the overall cost saving tips here, you've got to repeat these steps continually. It's not a one-off exercise. Get your IT team on board to find the right balance between preventative maintenance, policies, and innovation. So what I mean by that is that if your IT team just say everything's locked down, you can't deploy a data warehouse, for example, that's okay, but you might be forcing someone down a route where they use a SQL database where they should have used a data warehouse. So you want to make sure that you're not starting innovation. That's very tricky. It's not a technical problem. It's very important that you get buy-in from the top of your organization to build a data-driven cost culture across your organization. This is why this is not a technical issue. This is a process and business issue. And that requires education to all your different stakeholders. I'd recommend if your business contracts out work, so as a consultancy, we're always working for other customers. As a vendor, we will always include cost optimization in our development process, and our managed support service has cost optimization built into it. So we'll make sure your cost is as low as possible when we support your modern data platform. Make sure that your vendor of choice does these things in their statement of work. The other thing I'd recommend at a high level is do not try and do this stuff manually. It's too big. It's impossible to keep track of it. Automate as much as possible. Everything's got an API. Everything's got runbooks and Python scripts. There's really no good reason why you shouldn't automate it. If you haven't been empowered to automate, then make sure that you work out how to get empowerment from the people above you to do this. Like I mentioned earlier on visibility, the tools are not great. Extract the data and connect your own tool of choice to it. You'll get much better results. Which brings me to my next point. Consider investing in an automated cost management tool like Cloud Monitor, Cloud Health, ShareGate Overcast. There's quite a few different tools in the market. These tools are designed to solve some or all of these problems, but they do it automatically, so that you don't have to invest in this. So if a license for a tool costs $1,000 and it saves you $20,000 a year, that's a $19,000 save, and it will free up your staff to work on more important things. So I'll just give you a little bit of overview on Cloud Monitor. So this is actually a tool that Data-Driven have developed. So we've taken our experience on customer projects and all these cost optimization learnings that we've had over the years, and we've turned it into an automated tool that sits in your tenancy and does these things for you. So the first thing it does is it looks at metrics and utilizations for right sizing, unused resources, opportunities, and it lets you know about them. And this is in addition to the cloud's core recommendation system. So it's there's a whole lot of custom rules that it can run on your system. Secondly, we have very good cost anomaly detection. So as I said, if your costs go up, it shows you an audit log as to what happened yesterday, so you know why, and you can pinpoint what changed, which is the hard part of cost anomaly detection. We also have budgets that let you set pace as opposed to just a straight budget, so you can understand whether your forecast will be out, and those alerts go to the owner, so it lets you start in that feedback cycle as quickly as possible. We also have the concept of every single resource has an owner and a credit date. We don't do this with tagging, so we have a much more robust system than the freeform tags. We have a concept called a cost group, which is a collection of resource groups, resources, and subscriptions for business unit. Now, that cost group has an owner, and they can change the resources in that. And all the budgets, the alerting, the cost anomalies, the recommendations are all set at the business unit level. We have self-service reporting with budgeting and forecast and scheduled reports to business owners. We have an embedded bot that lives in your Teams or Slack dev workflow. So a good example, in Databricks, if you don't select scale down your cluster automatically, and it just sits there using up compute, it's not actually even running compute, but it is costing you money. Cloud Monitor will basically send you an alert in Teams saying, hey, you can scale this down. So it catches the cost mishap immediately, as opposed to 1 month later when you try and work out why your costs were so high. All of these learnings were based on real examples that happened in our team, by the way. We also do intelligent alerting. So we leverage multiple Microsoft 365 channels, to-do list, reminders, mail, Teams, all that kind of thing, to make sure that you're always across what's going on in your system. And we have smart scheduling. So if your customers are only running 40 hours a week, why would you run your services overnight, on weekends, public holidays? You can set up as many different schedules as you like and assign them at the top level cost group, and all the resources in that cost group, if they can be paused, they will be paused, and they'll be restarted the next time the schedule fires. But you don't have to do any other stuff with scripts and messy code. It's all built into the product. As an example of the kind of reports that Cloud Monitor gives you, so it gives you very advanced ways of finding out where your costs are. So here, this is a decomposition tree. It basically, I can drill down into all these different subscriptions or services and work out what's costing me money. Every resource group, subscription, cost group has an owner, and the data was created on, so it's much easier for accountability. Cost anomaly detection. If there's a spike in costs, the owner will get an alert, and we've got some very cool reporting as to what's happening to your costs, and this is updated daily, so it's very powerful. So check out some of these tools. Go to cloudmonitor.ai, check out Cloud Health from VMware. ShareGate Overcast is another great one. They do all the stuff for you, so you don't have to. Okay, and that note, I'll see if there's any questions. I'm sorry I had to rush that a bit. Sarah, do you have any questions?
Great, thanks Rodney, and thanks to everyone for sticking with us for the extra 10 minutes. We do have about 4 questions that came through, so we've got probably about 5 minutes to answer them. So first question, Rodney, we have is there an easy direct way on Azure portal to find long unused resources?
No, there's no way. If you think about what the definition of an unused resource is, so let's consider a SQL database. There's 2 planes to it. There's the data plane and the management plane. So I can look at the activity log, and this is all via code. This is not via the UI. I can look at the activity log, and I can say, show me who last, or when did someone last change the management plane of this resource, and that's one aspect. But if I want to see who accessed the actual SQL database via, the actual data, that's a different question. No one could have changed the resource, but someone could still be accessing the data. So there's a whole lot of different aspects to determining whether a resource is unused. That's pretty complicated. So the short answer is no. It's something that we tackle in Cloud Monitor. We do things like looking at both planes and coming up with a best guess as to when it was last accessed, and then putting that information into a report for you to take action on.
Great, and so we've got another question from Yas. What's a good benchmark/threshold in CPU/compute usage for right sizing of resource?
So it's a good question. It's unfortunately no simple answer. It's going to depend on the workload. So each workload will have different requirements. There's a lot of different metrics in a VM. It's not as simple as saying, for this workload, I can take an aggregate of these measures. You have to think about what it's doing. If it's writing to disk a lot, if it's has a SQL database on it, what is the purpose of that VM? There's no short answer to that. You probably want to have some buffer as well to make sure that if you set the threshold too high, you're not going to affect performance. So you'd probably have an ample buffer to make sure that you don't affect performance.
Okay, great. And another one from Yas, he said, not every resource has built-in scheduler. How can schedules be made in such case?
So the current way people do it is they define the requirements for the schedule they want. They use something, they basically code the schedule. So they say, okay, if it's a weekday, I go and fire an API. So in Azure, there's automation runbooks, which basically host some code, and you can write Python, PowerShell, C#, whatever you want to write. Or you could write a Lambda, and you could say that, put this onto a schedule. Or you could use the orchestration features of Data Factory. There's a whole stack of different ways of doing this. Ultimately, it's all checking a schedule, making a business decision as to whether it needs to be paused or not, and firing an API.
Great. And one last question is, what are some other PaaS, so PaaS services that can be used like Azure Functions to lower costs?
I'm not too sure the question. I think what you're asking is, okay, so functions should be your first port of call for PaaS. So consumption-less serverless functions are amazing. In Azure, you get 1 million free hits a month, so you can do most things. You have to be aware of the timeout. If it's a long running function, you won't be able to use a consumption plan, but there's architectures to get around that. The next service up from that is, I would say, Serverless Sql Databases. So in Azure, you can, for the last year or so, we had this concept of you're basically paying per query. It spins up, executes a query, and spins down again. So it has no cost at rest. That's in the kind of relational database area. And then storage accounts are very versatile in Azure. So a storage account has queues, tables, blob, and file shares. And often storing JSON data in table storage will be much cheaper than using Cosmos DB, for example, or MongoDB for JSON data.
All right, and one last question that just came through now is, how can we efficiently update the data in destination system if the source system is getting changed frequently in real time?
So if I've understood the question correctly, you've got a data integration system and you want to duplicate data between them. So when a change is made in one system, you push that change to the other system. There's no way around that. You're going to have to push those changes. So you could ask questions like, can we batch those changes together? Do they have to be in real time? What's the latency of the change on the target system behind the source system? That requirement on latency is going to basically either escalate your cost ridiculously or not. So it often comes down to latency as to how expensive and what your architecture needs to be. If it needs to be immediate, you could use something like an event bus or a service bus that's pushing every single event out to the other system. But I think you'd have to start with the requirement and work out the latency before you can answer that question.
Okay, great. Well, that was our last question for today. So thank you so much, Rodney, for the presentation, and thank you to everyone for tuning in and for the great interactive questions we had there towards the end. You'll see I just put up on the screen a link to our survey with the event code there. So if you do have time to fill out the survey today, that would be great. And thank you for staying on for those extra 10 minutes. We're also sharing with you a link to Sydney's upcoming events, so just check out our meetup page for any future events that we do have, and also the link to the YouTube channel. So if you did have to leave this session 10 minutes early today, this will be uploaded to YouTube by the end of the week, so you can catch whatever bits that you've missed and share it with your network. So thank you again to everyone. Have a good rest of your afternoon, evening, morning, wherever you joined us from today. We'll see you next time for another Microsoft live stream event.
Thanks all. Bye.
Thanks, Rodney. Bye.